Hello students, welcome to this class of fluid mechanics. So as you know, currently we are studying about the flow in pipes, right? So in the earlier classes we have solved some numericals. Before that we have discussed about the various energy losses that could occur in a pipeline, right? I hope you remember we have studied about energy losses, right, in pipeline. Then we have talked like there are one is major losses and another one is minor losses, right? One are major losses and another one is minor losses. The major losses we used to calculate by Darcy's equation or Chassis formula, right? We have studied this both and we have solved some numerical based on Darcy's equation. Okay, major losses basically occur due to fluid friction, right? Due to fluid friction or viscosity. Fluid friction or viscosity. However, there are minor losses also. We have discussed that minor losses could be occurred due to sudden change in area, okay, sudden area change, or it could be occurred at the bends. There are various bends in a pipeline. There are also some losses, bends, or there could be pipe fitting, okay, at the pipe fittings, or let's say there is some obstruction to flow, okay. If there is some obstruction to flow, then also the losses are there. So this part, major part, we have already discussed, okay, already discussed. So today we will study minor losses, that is how to calculate minor losses, okay. So we will study minor losses one by one, okay. So in this class we will study basically about three types of losses, and we continue on minor energy losses in next class. So first of all, this is a part 1 of minor energy losses. Loss due to sudden enlargement of area, that is, if area is suddenly increased, then there are some losses. Every eddies formation is there. We'll see what I mean. Let's see, I have this pipeline, okay, and then let's say here the area increases suddenly. Let's say in this direction I have a flow, this is my pipeline, and there is a, and what will happen as the fluid pass from here, it will go like that, right? Let's say here fluid is coming at v1 velocity, okay, let me fix my control volume, and it's getting out at v2, okay. Let's say here I have area a1 and here the area is a2. Then here will be a eddies formation, okay. We have already studied what is eddies, what are eddy formation. So because of this eddies formation there are some losses, okay. So how that losses are calculated, we basically calculate it in the form of head. So the head loss due to sudden enlargement of area is equal to H is equal to V1 minus V2 whole square upon 2G, okay, this one. So initially the area is initially the velocity is V1 and the final velocity is V2. After the sudden enlargement of area, the head loss due to sudden enlargement of area will be, remember this is not a total loss, this is only a minor loss. You still have to calculate the major loss using Darcy's equation. Similarly, second case, here we have discussed about sudden enlargement. Now we will see sudden contraction, okay. if there is a sudden contraction, that is if area is reduced suddenly, like this. Okay, let's say I have a fluid flow in this direction and my area is reduced suddenly. Then here I have a flow. Let's say here is pressure P1 A1 and here I have P2 A2. Okay, this is section 1 and this is section 2. Then head loss due to friction will be equal to 0.5 or 1.1 by 2 V2 square by 2G. Okay, here V1 is not considered, just V2 is considered. Okay, so head loss due to sudden contraction will be equal to 1 by 2 V2 square by 2G. Okay, so we have seen the head loss due to sudden enlargement of area, then head loss due to sudden contraction of area. Okay, now we will see another type of loss, of minor loss, that is loss of head at entrance of pipe. Okay, loss of head at entrance of pipe. What do I mean by this? Let's say I have a tank here consisting of some fluid and here is my fluid. So this is the entrance, right? Entrance of pipe. So in this direction there is a velocity V. So here the flow rate will be, here the head loss is same as sudden contraction. Here H will be equal to 0.5 V square by 2G. Okay, so this is the head loss due to minor loss at the entrance of pipe. Keep in mind that these are only the minor losses. To calculate the total loss in any pipeline consisting of any flow, you need to calculate major losses as well as minor losses. Both major losses you can calculate by using Darcy's equation, and minor losses, here as we are discussing, we have discussed the three cases: loss due to sudden enlargement of area, loss due to sudden contraction, then loss due to entrance of pipe. There are 4 more cases that we will study in next class. Fine, we will meet in next class. Bye bye.